Good morning, students. This is Anjali, Assistant Professor, Department of CSE, IARE, Hyderabad. In last session, we have seen that some topics which are summation, proportional, dot product, graphs, and algorithm or exponent. That means actually near about everything in data science, summation, proportional, dot product, graphs, and logarithms. All things are added in the data science, and every operation is performed by the data science for the particular task. Summation is showing the summation of the number, and it is we can show as a sigma by using the sigma symbol. Then proportional, obviously when we are talking about the professional, then we can see that we can show the by using the alpha symbol, and this proportional is showing that one factor is affected on the another and another factor is affected on the first factor. That is, both factors are depending on each other. This is showing the proportionality between the two factors. Then dot product, we can show the dot product, we can perform the dot products in the matrix, in the vector. Then we have seen that the graphs, and every graph is very important. We have find out the some coordinates. We know that when we learned about the graph, at that time we have shown that x and y both coordinates are very important for the graph. Then logarithms and exponent. In logarithm and exponent, we have seen that uh, log and log and exponent both are related to each other. Right? This is the all about the last session. Now we will see the set theory, set operations, linear algebra, and matrix multiplication. First, set theory. I know that everyone has learned about the set. What is meant by set? We can say that a set is a collection of different elements. Set is a collection of non-duplicate elements. We can say even set could not contain the duplicate elements. That means set is totally related to the mathematics. And we can say that the set theory involves the mathematical operations on the set level. Sometimes thought of as a basic fundamental group of theorems that governs the rest of the mathematics. Whenever it's about the set, it can contain the some element, it can contain the some value, it can contain the some strings. That means, in general word, set is a group. We can say set is a group of elements. Even for our purpose, actually we use the set theory for manipulating the group of the elements. And these group of the elements are very important for the manipulating, for the accessing the data. And the set is, we can say, collection of distinct objects. Obviously, set can contain different type of object, different types of values, different types of alphabets, and different type of characters also. That means a set can be thought of as a list in Python, but with no repeat object. We know that set will not contain any repeat object. If there are some duplicates of the object, if there are some duplicates numbers, then definitely when we will execute the program, then automatically it will remove the duplicates object. For example, for creating the set, we have used the set function, and we used set function in the S. We stored set function in the S. Set function, then S is equal to set of, I provided the some data. That means, and I provided the data, but with a duplicates value. But when I will execute this program, it will remove the duplicates of the list, duplicates from the list, and you will get the output s is equal to 1, 2, 3. And automatically, when we will talk about the set, then automatically it will strike that we used to write the set in the curly brackets, and without curly brackets set is the incomplete. So there is need to use the curly brackets, there is need to use curly brackets and put the values in between the curly brackets. Now the magnitude of set is number of elements in the set and is represented as the follow. Obviously, when we have to find out the magnitude, this is your magnitude, and we can say that it is the magnitude of the A. Concept of empty set exists and is denoted by the character. And this null is said to have magnitude of 0. If we wish to note that element is within a set, we use the epsilon notation. That means we can say that 2 belongs to the given set. 2 belongs to given set. We know that we have set 1, 2, 3, but we can say that we have 1, 4, 5, 9. Now I have to check that 3 is a member of given set. Is the 3 member of given set? Definitely we will say no. 3 is not a member of given set. But if I ask the 5 is the 5 the member of the given set, then definitely we can say that 5 is the member of the given set, and that means we can write like this: 5 belongs to the given set. 5 belongs to the given set. Now, this means the element to exist in the set of 1, 2, 3. If one set is entirely another set, then we say that it is the subset of the larger counterpart. For example, we have taken here set A and second set B. Set A has 1, 5, 6 and second B has 1, 5, 6, 7, 8. But now we can observe that the values of set A all are present in the set B. That means we can write this: A is a subset of B. A is subset of B. So A is a subset of B and B is called as the superset of A. We can say that B is a superset of the A. If A is a subset of B, but A does not equal to B, we can't say that A is equal to B. Actually, A is not equal to B because values of A are involved in the B set B set. That meaning that there is at least one element in B that is not in A. Then A is called proper subset of B. A is called proper subset of B. For example, a set of even number is a subset of all integers. We know that which numbers are integers. That means we can say all even numbers are involved in the integers. Every set is a subset, but not a proper subset of itself. A set of all tweets is a superset of English tweets. All these are examples of subset and set. Set, subset, and superset. Actually, in data science, we use the sets for representing the list of objects to generalize the behavior of consumers. It's a common to reduce customer to set of characteristics. Consider that we have a marketing firm and trying to predict where a person wants to shop for clothes. We are given set of clothing brands the user has previously visited, and our goal is to predict a new store that they would also enjoy. But suppose a specific user has previously shopped at the following store. For example, I have a user one. I have a user one. I used here Target as function, then Banana Republic and Old Navy. And we have used here curly bracket for creating the set. And we are comparing those sets list by using the square bracket. Now, user one has shopped at the Target, Banana Republic and Old Navy. But let's look at different user. We will see now we have user 2 and user 2 have Banana Republic, Gap and Coles. Now we are wondering both users have some similar values, and with the limited information we have one way to define the similarity to see how many stores they are that they both shop at. And that means both the user 1 and user 2 went for same shop. So that means we can say that it is the intersection. It is the intersection. It is showing the common value. It is showing common value. So we can say it is the intersection. An intersection of two sets is a set whose elements appear in both the sets. And actually it is denoted by the symbol intersection. Now we have user 1 value and user 2 value. You can see that this is user 1 value and we have Target, Banana Republic and Old Navy value. And now we have second user 2 values, Banana Republic, Gap and Coles. That means Banana Republic in user 1 and user 2 both are common. So we can find out the user 1 intersection user 2 is equal to Banana Republic. And from this we can find out the magnitude of user 1 intersection of user 1 and user 2, and we know that there is only one value, that's why our magnitude is also 1. And intersection of two users is just one store. However, each user has 3 elements in their set, so having 1 by 3 doesn't seem as a bad. Suppose we are curious about how many stores are represented between the two of them. For example, and actually we have to find out the how many stores are representing both of them together, so we can show as a union. And this, for this purpose, we can show as a U. The union of two sets is set whose elements appear in either sets. It is denoted by this symbol. And for this purpose, we can say write that user 1 union user 2. And obviously, if it is the set, so we have to denote in the curly bracket. Now we can write the Banana Republic, Target, Old Navy, Gap and Coles. This is our set. We can't repeat the values. So user 1 union user 2. We will collect the all values. But now we have to find out the magnitude of user 1 union user 2. So there are 5 values 1, 2, 3, 4, 5. That means our magnitude will be 5. When looking at the similarity between user 1 and user 2, we should use the combination of union and the intersection of their sets. And user 1 and user 2 have one element in common out of the total of 5 distinct elements between them. Obviously, we can define the similarity between the two users. But how we will show the similarity between the two users? For this purpose, we have to use magnitude of user 1 intersection user 2 divided by magnitude of user 1 union of user 2. Intersection of user 1 intersection of user 2, we have to find out the magnitude, and after that we have to find out the union user 1 union user 2. Now we know that value of user 1 intersection user 2, magnitude of intersection of union 1 user 1 and user 2. So this value is only 1, and after that we got the magnitude of user 1 union user 2, 5. That means it is showing the similarity between the two users is a 1 by 5. In fact, this has the name in the set theory. Actually, it is the called Jacquard measure. And in general, for the sets A and B, Jacquard measure between the two sets is defined as follows. And for Jacquard measure, we will use as J of S. J of S. We have to consider two sets A comma B. We considered here A comma B, and we have the formula A intersection B and divided by A union B. When we are finding out the similarities between the two sets, then we can use the Jacquard measure. And Jacquard measure formula is magnitude of intersection of the sets and magnitude of union of two sets. It can also define as magnitude of the intersection of the two sets, which is divided by the magnitude of union of the two sets. This gives us a way to quantify similarities between the elements represented with the sets. Now, actually the Jacquard measure generally is a number between the 0 and 1. And when the number is closer to 0, people are more similar to or more dissimilar. They have not any similarities. But when the measure is closer to 1, then we can say that there is a similarity. When it's closer to 0, we can say when it is the closer to 0, then it will show the dissimilarities between the elements. And when it is closer to 1, then we can say that it is showing the similarity between the elements. Now, if we think about the definition, then it actually makes the sense. Now, look at this formula. Jacquard measure of set A and B. There is a formula, number of stores they share in the common. That means intersection. And unique number of stores they like combine. Here, numerator represent the number of stores that the user have in common, and denominator represent the unique number of store that they put together. Here you will get the unique number. Here you have to write the intersection. Now we can represent this program, this Jaccard measure program in the R also. And obviously, when we have to find out the values between the sets, Jaccard values between the two sets, then we have to execute this formula. We have to declare the set of A and set of B. For this, we have set A and set B. I used here the C function. By using C function, we have to create the vector, and after creating the vector, you have to use the Jaccard function. And by using the function, I provided the sets A and B. And by using the Jaccard function, I used the open curly bracket and I wrote here some operations. And there are some operations means first I wrote here intersection, and intersection, then union, and I used here return. So first you have to find out the intersection. So here you have to use the intersection is equal to length of intersect of A and B. Now you will get the intersection of the value. Then union. Now you have to find out the length of A, length of B, and whatever you got the intersection value, you have to subtract this value. After that, you have to return. You have to use the return function. So here you will use the intersection divided by union. And after that, you will use the Jaccard function, Jaccard with the A of B. Now, after executing, you will get the something 0.29 sum. This is your answer. And the set theory becomes highly prevalent when we enter the world of probabilities and also when we dealing with the high dimensional data. Actually, it will use some sets for representing the real world events which are taking the place, and probability is becoming the set theory with the vocabulary on the top of the it. And the Jaccard similarity generally measures the similarity between the two sets of data to see which members are shared and distinct. The Jaccard similarity is calculated by dividing the number of observations in both sets and by the number of observations in either set. Now there are some set operations. In set operations, R includes some set operations. For example, first one, union of xy. Union of xy means both the values of x and y will store in the one set. Then intersect of xy. It will show the intersection of the sets x and y. That means it will show the common value between the two sets. Then set diff of xy. That means it will show the set difference between the x and y which are consisting the all elements of x that are not in the y. Then set equal xy. It will test for equality between the x and y. Then C percent in percent y. That means here we have to check the membership, and it will testing whether C is an element of the set y or not. And choose nk, number of possible subset of size k chosen from the set of the size n. This is all about the set theory. Now we have to find out this just Venn diagrams How you, and you have to verify the identities. First one, A equal to A intersection of B union A minus B. How we will get we will get set A. Here A intersection, that means these are our two sets, set A and set B. First, you have to find out the intersection. So, this is the common factor. Then you have to find out the A minus B. A minus B means from A, we have to remove the B. And obviously, these are the our sets. This is A and this is B. So, when we will subtract the B from A, then definitely we will get this portion of A. We are not including this one. So whenever we will subtract this thing, so we will get the only A, and this is A and B, and this will be A. This is your A. This is your A intersection B, and this is your A union A minus B. Now second one, you have to find out if A and B are finite set, then we have magnitude of A union B, A set, B set minus A intersection B. Now we will find out this one. A union B. A union B means we know that if we have the both set A and B, then both set will include in the set. If I asked A intersection B, then A intersection B means it will contain the common portion between the A and B. If I asked here magnitude of A, that means it will contain only A set. This is your magnitude of A. And if I want only magnitude of B, then A, B, then definitely this is your magnitude of B. These all are the diagrams of the some identities, and we have find out that Venn diagrams. After that, we will start the linear algebra. Linear algebra is the study of linear combination. Study of linear combination, and actually it is the study of some vector spaces, some line and planes, and some mappings which are very required to perform some linear transformation, and this includes vectors, matrices, and linear functions. And actually it is the study of some linear sets of equations and its transformation of the properties. Now we will see the matrix multiplication. Like matrix can be multiplied two ways, in scalar multiplication, or we can perform in multiplication with another matrix. First is scalar multiplication. Actually, it involves the multiplying a scalar quantity to the matrix. And every element inside the matrix is multiplied by the scalar quantity for performing a new matrix. We have some matrix. For example, this is our matrix and we are calculating by 5. Now, this 5 will calculate with the every element which are available in the matrix. 5 into 5, 5 to 7, 5 12 of 60, 5 3. That means it will calculate with every element. And now we will get as a result this our matrix. And multiplication of matrix with another matrix means here two matrices can be multiplied if and only if number of column of first matrix is equal to the number of rows of the second matrix. Here you have to consider M1 and M2 having the order or having the dimension M1 by N1, M2 by N2. And this matrix can be multiplied if and only if N1 is equal to M2. Now you can see that here 1, 2, 3. That means this is our matrix which is containing which has a dimension 1 by 3. Now it will calculate 1 will calculate 2, 1 into 2, 1 into 3 and 1 into 4. That means everywhere it will calculate 1 into 2, then 2 into 3 and 3 into 4. Then again 1 into 1, 2 into 3, 3 into 1. After that it will calculate with the third column, then 1 into 3, 2 into 2, 3 into 2. That means this is our matrix, and now we will find out this value. 2 plus 6 plus 12, 2 plus 6 plus 3, 3 plus 4 plus 6. And now we have these values 20, 10, 20, 10 and 13. With our this result this is the result, and which has a dimension as a 1 by 3. Now the matrices given above the satisfies the condition for matrix multiplication. Hence we can say that it is the possible to multiply those matrices. And the resultant matrix obtained by multiplication of two matrices is order M1 and 2, where M1 is the number of rows in the first matrix and N2 is the number of columns in second matrix. And for this purpose, you have to know the some rules of the matrix algebra. The algebra of matrix follows some rules for addition and multiplication. Let's consider three square matrices A, B, C. This matrix is a transpose and A inverse is the inverse of A. And I is the identity matrix and R is a real number. Now, here are some rules of transposition of the matrices. Whenever you are writing, you are showing the transpose of transpose, so you will get the same value. After that, whenever you are writing AB of transpose, it will distribute to both values. In multiplication also, AB and then ABC. Again, this is also we can say multiplication, so it will distribute the values. Then inverse rules of the matrices rule. This is inverse. Inverse A of I. I is equal to I of A. That means here from here I will cancel and we will get the A value. A of A inverse or A inverse of A is equal to I. Whenever you are writing A inverse of inverse, it's equal to always A. And when you are writing A inverse, now you will distribute the A inverse, B inverse and A inverse. Here ABC inverse, ABC inverse, that means C inverse, B inverse and A inverse. And now A transpose of A inverse is equal to A inverse of transpose. These are the simple rules. When you will solve problems of the matrices, then you can use these rules. Now we have the one problem. We have to matrix A and matrix B. We have to find out the A plus B, A minus B, A into B. Now we will find out the A plus B. It's simple things. 3 plus 1, 4, minus 5 plus 4, minus 1, minus 1 plus 8, 7, 7 plus 3, 10. Now we have to find out the A minus B. For this, 3 minus 1, 2, minus 5 minus 4 minus 9 minus 1 minus 8 minus 9 7 minus 3, that is 4. Now we have to find out the A multiplication of B, and A multiplication of B means 3 into 1 3 minus 5 into 4 minus 20 minus 1 into 8 minus 8 and 7 into 3 means 21. This is our matrices. Now these are the problems which we have solved. Now same things we can find out the answers by using the R programming also. This is the program. This is R program. So first I provided X value. I created the X vector. X, I provide the input by using C function 2, 4, 7, 5, 10 and 1. Now I used here A as a matrix. Then X comma, I declared here number of rows 3. Now I have to print the A, and when I will print the A, all these will print in the matrix form. Then after that Y will print by using the same functions, but I used here A matrix and B matrix. And here also, and rows are 3. That means you have created the matrix by using the R programming, and now you can directly perform some operations. And which operations? A plus B, A minus B and A multiplication B. When you will execute these functions, when you will execute these operations, you will get the A plus B, values of A plus B, then values of A minus B and values of A multiplication of B. This is all about the set theory and linear algebra. These are the some references, you can refer it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.